Hello, everyone. I hope that you're doing fine. And at this series of topic, I'll be talking to you about wireless sensor networks. My name is Tamo. I'm a professor at School of Information at the Rochester Institute of Technology. So sensor network is comprised of a large number of sensors. There are many different applications. But sensor network, when you think about it, is a lot different from existing network, which behaves a lot different than the sensor network. It's a densely deployed, very closely. It could be very wide, a number of different way, and there could be a deployment could be differ. There is a random deployment. For example, one of the thing is from the airplane dropping a lot of the sensor to the ground, and there are some application regarding that, measuring the moisture of the forest or desert or certain weather, ground behavior. So I see plane dropping. We're talking about thousands of sensor are dropping on the ground. One thing is that once it drops, you will communicate with one another, and basically relaying the information towards the destination. And one other thing is, once you drop the thousands of this on the ground, it could be raining. There are a lot of different patterns of weathers involved. And gradually, when battery runs out, it gradually, what do you call it? Falls apart. It goes into, it doesn't affect the environment much. It's not like a plastic or something that hangs around. It's dissolved into the environment. So that's one of the application for random development. There's also cooperative capability, is that a lot of the sensors, it works together. It's not just one independent functionality, independent capability. It performs a lot of the functions somewhat together. So you need to consider that as well, okay? Let me see, let me do some little bit of adjustment here, okay. Okay, maybe it's a little typical. Okay, so so there's a difference between, I don't know you aware of ad hoc networks. Ad hoc networks is relaying the information from one node to another. A lot of these cases wirelessly. It's piggyback on the information from one node to another. For example, if there's a 3 nodes, right? The node A, B, C, and when A sends the information to B, whatever the information from A, it piggyback onto the B's information, send it to C. So that's more of an ad hoc network cases. I worked in this area for a number of different years, especially a mobile ad hoc network in the military. And that's somewhat similar to sensor networks, but it's just somewhat different. The one thing is different is a number of nodes in the sensor network that can be order, magnitude of thousands or hundreds. When we talk about ad hoc network, we're talking about vehicle ad hoc network, as you see in the vehicular networks, or when I was in the military, it's a mobile ad hoc network. Those are the two different cases. And also sensor nodes are densely deployed. It's much closer, and the ad hoc network, especially in the vehicle, it has a longer range of communication between the vehicles, right? But sensors, we're talking about very short range. So if it's long, and also remember that the sensor nodes are operated by the battery mostly. It can be powered from the electrical, but many cases uses a battery for you know, you know, you know, for the each node for the power and delivering the message from one point to another. Another thing is a sensor nodes are prone to failure. That's somewhat expected, right? So you don't expect the sensor nodes to 100% working perfectly. That's why there has to be a lot of duplicate backup of it. If one node is not able to pick up the information, you kind of expect that the other nodes pick up the information. So this is somewhat different. And for the mobile ad hoc network, vehicular area network, we need to have expectation that every vehicle working properly, but sensors not, okay? So another thing is the topology of sensor network changes frequently. And also the mobile ad hoc network, this topology change pretty frequently as well. But a lot of the sensors change frequently when you're talking about the mobility, okay? If it's a static, that's not the case, but some cases sensor frequently, network changes, especially in network topology. So another thing is sensor mainly, but there are two different, deployment. The sensors are more of a static. It's kind of implemented into the network, and it doesn't move. But some are dynamic. It tends to move very frequently to one point to another, and that's another thing. So you need to consider. Okay, so one of the example I should say is, so sensor device that you're carrying as a human, you go from one place to another. So in that sense, dynamically it changes. For example, there are a number of students carrying the mobile device, which has a lot of sensors, right? So it changes frequently, so you have to consider that. Sensor node mainly uses broadcast. You need to understand the sensor node is small. It doesn't have a lot of processing power. It has a very limited amount of memory. So it can have a big brain power, be able to deliver the packets, sophisticatedly to the destination. So mainly a lot of sensor mainly a broadcast, hoping that another sensor picks that up and relay to another sensor. So don't get me wrong, there's a sensor does ad hoc, but there's a central version of it. All the sensors sent to the central location. That's another strategy, okay? So sensor nodes may not have a global ID, doesn't have a unique ID. That might be the a case because there's so many of them. So you may not need a global unique ID for it, okay? So when you look at the sensor network internally, so these are the minimum component it needs to have. We're talking about CPU, processing power. It could be it's very low, CPU. The another thing is a power supply. We're talking about the power supply is battery power, right? Not electrical power. It can be electrical power, but what kind of battery supply are we willing to use? Sometimes it can be electrical plug-in. Sometimes it could be more of a battery. And the sensor to detect senses and being able to communicate. This is the one important things, being able to communicate with Wi-Fi or Bluetooth or infrared, whatever that is. And typically, this is the minimum amount of component it needs to have. Okay. So this is the minimum. So it's current sensor node platform. There's Sensoria, Wind, SmartDust, Berkeley. This is one of the first sensors back in 90s. It was kind of created for research purpose. It became pretty popular. There are many sensor nodes out there, and when they created, it became pretty popular at the time. But it was not reliable sensor node, I should say. Okay. Okay. So So operating system, one of the first operating system for sensor node is a Tiny OS. It was custom built in UC Berkeley for wireless sensor node. So I want you to remember that you cannot use Windows or Mac operating system. It's too heavy. It requires a large amount of RAM and also a large amount of processing power to use those, even Android and iOS. So they have to come out with a very simple operating system, and they came out with a Tiny OS. It's a very simple operating system that can handle by sensors. It's a component-based architecture, ensures a minimum code size. There was a number of component library, network protocol. There's a sensor driver. There's a data acquisition tool, the distributed server. There was a few of the tools available in those tiny operating. And another thing is, I want you to remember, sensor you might be thinking of as a very small sensor. This is a Berkeley mode. This is very, battery operated, very low processing. It can go up to, AWAC here, and this is a more of a, civilians, detecting radars, detecting objects in the sky. So this is a huge sensors, right? Compared to this. So I want you to know that there are different sizes of sensors available, okay? So another mode, uses, IoT. One of the first sensor is that they can create a crossbow Mika 2 modes. This is one of the first researchable IoT device, which has sensors as well. Okay, I need to stop and I will start again, okay?